Okay, we're back. So now let's move same geometry, but the 3D ones. Okay, so here my workflow, I have it here in the bottom. So pretty much the same. So mesh, oops, I need to put it here and double click. Let me save this project. So we put it here and we're going to import everything that we have in geometry in the 3D. So remember that we have two volumes, two solids, and one surface. Okay, and the idea is to do exactly the same that we did in the previous case, okay? But it's 3D now. So it is important. Okay, sometimes take longer when you start to have solids. Okay, so this is what we have, and see that you have everything that we led, but that we didn't suppress in space when you have it here. So I don't need this one. Let me suppress, okay? And like in the previous case, you have these two, and you are going to do the same selections. You're going to use the same method. Look at that. We have here already. We have the named selections. So let's do that. So let me hide this, okay? I don't need this, or let me suppress for the moment, okay? And what we're going to do here, again, go here, always CFD, and let's insert a method, okay? Method, select the whole stuff, and see that the method that we're going to use here is extremely important. Sweep method, sorry. And here, algorithm, this is how the program control, or you can do it manually if you want, you have the option. But here, source target selection, you need to choose source and target face, okay? So in this case, it's simple, is you leave it automatically. I think Ansys will do the right selection, but if you want, you can do it manually. So you can do like manual source and target. So see, the source is this, and your target is this. So if you put automatically, Ansys measure will do the selection. So it's up to you. I like to do it manually, even if I know that probably automatic will work fine. I like to do it manually. Free face, I want everything 3. So the triangle, so this is equivalent to choosing on the 2D triangle or quadrilateral, everything. And see here, number of deviations. Here you choose how many distribution, how many cells. So you put just 1. Generate, and this is it, okay? You have your mesh, and then you can add the size and everything like in the previous case. So see what is important here, we're putting just one cell here. So you put 2 cells, now you go fully 3D, okay? So now you're going to resolve the flow in these directions. But if you put 1, and by using the right boundary condition, symmetry in front and back, it will be like a 2D case. So now let's add here the refinement like in the previous case that I already have it here open. So we have edge sizing 11002. So this is exactly the same. So let me add a sizing. So remember, we're working in a phase, so you need to select the edges and everything like in the 2D case pretty much. Apply there, this sizing there was 002, and this was 11. Okay, if I press generate, see that you have your mesh there. Okay, see that it still is 2D. So many software work like this, okay? Fluent gives you the option to do 2D, but for instance, CFX work like this, and many commercial open source software also work like this, that even if it's 2D, you need to give this unit depth. Well, not necessarily have to be a unit depth, but it's recommended to have a unit depth. Okay, so now you add the inflation layer. So it is in exactly the same way. So you choose this face and then add in this edge, and we want 8 there. Generate. And there you go. So you have your boundary layer there. And now we can also press this one. And see that you have the body there, and you can do exactly the same step here. Insert, sizing. So you want here, and this one you want to do body of influence. See that it becomes available when you have multiple bodies. So that this apply, and then put the dimension there that here I chose. In this case it was 0.2. So let's put there. So inside this, everything that is contained in all the cells in this is called geometry that is contained here would be set to this element size. So you press generate. And this is it. Okay, let me hide this one. I don't need here this. I bought it. And there you go. Pretty much same geometry. So see that even if you refine there, see that it's always 2D. Okay, you have that extrusion 2D and exactly the same geometry. So that advantage, as I mentioned, is this, that now when you post-process, you will have the phase. So here, for instance, you want to visualize Y plus, it's easier to visualize Y plus, pressure distribution, everything. Okay, so I like to do it like that. And just to convince you that you are not adding more cells, so as you go here, see that your statistics are the same. Well, in this case, we have less, but probably we didn't choose this exactly the same parameters. But see that you didn't double or triple your cell count. Okay, it's pretty much the same. Okay, so see that here, you go here, you have this. Okay, and in this case, you have this. Okay, so you are not doubling, tripling the quantity. So this is my preference when working into the LI to do it like this. Remember to set up your boundary, your named patches, and important that these two phases also you need to set up. So if you don't give names to this one, Fluent will automatically group everything. But when you start to set up your case in Fluent, remember that this needs to be symmetry and symmetry in the setup. Okay, and it's recommended to have the phases independent. Okay, so that's all. Okay, this is the case. And this is the mesh. So we saw two types of techniques now to generate the mesh when working in 2D. In 3D, we have seen that there is no need for this. So we can use the fully 2D geometry in a surface, or we can move to the volume, but using as a sweep. Okay, so this is all for the meshing stage. Next video, we move to the case setup. So for case setup, I will use this mesh. Okay. But later also I will show you the difference with the 2D mesh. So that's all for this video. Thank you for your attention, and bye.